So dear participants, in the last bit of discussion with the topics of Unit 1 of Programmable Logic Controller coursework, we will see that how process descriptions can be interpreted properly in terms of these ladder diagrams. We will carry out one example, and if time permits, then we will go for a couple of examples through which we can see that how ladder diagram is created from a process description. You see here, we take up a problem. Suppose there is a selection committee, and that selection committee has got 4 members. These 4 members include the chairman. Now, if the candidate has to be selected, at least 2 members should support him or her. At the same time, there is another condition, that if the chairman finds suitable, then you can select any of the candidate. That means that if the chairman wants, then he can select any candidate and he does not need support of any of the members. This is the situation. मतलब बहुत आसान है. एक सिलेक्शन कमिटी है, 4 मेंबर है, उसमें एक चेयरमैन है. कोई कैंडिडेट को सिलेक्ट करने के लिए 2 मेंबर की सहमति चाहिए, और चेयरमैन अगर चाहते हैं तो वो कोई भी कैंडिडेट को सिलेक्ट कर सकते हैं और उन्हें कोई भी मेंबर की सहमति की जरूरत नहीं है. नाउ दिस सिचुएशन हैज टू बी ऑटोमेटेड. ऑटोमेटेड मीन्स दैट एवरी मेंबर विल बी प्रोवाइडेड विद अ स्विच इंक्लूडिंग द चेयरमैन. सबके पास एक स्विच रहेगा और आउटपुट में एक बेल रहेगी. क्या करना पड़ेगा कि अगर एट ए टाइम कोई 2 मेंबर स्विच दबा देता है तो बेल बज जाएगा, कोई एक मेंबर स्विच दबाएगा तो बेल नहीं बजेगा. अगर वो मेंबर चेयरमैन ना हो और अगर चेयरमैन रहा तो वो बेल बज जाएगा. दैट मीन्स कि आपको जो कंपनी ने ये सिस्टम बनाने को दिए हैं वो क्या बोले हैं कि देखिए, आप हमें एक बॉक्स बना दीजिए जिसमें ये 4 अलग अलग स्विच हो, ये 4 मेंबर के पास रहेंगे, एंड व्हेनेवर ए कैंडिडेट इज सिलेक्टेड बेल बज जानी चाहिए. अभी आपको इसके लिए लॉजिक डायग्राम बनानी पड़ेगी. देखते हैं. स्विचेस को नाम देंगे पहले. लेट अस सी दैट द स्विच ऑफ द चेयरमैन, उसको हमने नाम दिया CH. स्विच फॉर द फर्स्ट मेंबर, उसको हमने नाम दिया A, एंड स्विच फॉर द सेकेंड मेंबर, उसको हमने नाम दिया B. और जो थर्ड मेंबर की जो स्विच है उसको नाम दिया C. So in all there are 4 members: chairman, first member, second member, third member, and switches are named as CH, A, B and C. Now you see, अभी हमको ये जो switch हैं, that switches have to be connected to the PLC input terminal, and therefore it is very much important we give proper address. While giving the address, we will be using Allen Bradley notation scheme. So this chairman's switch is connected to input terminal 0/1, A switch is connected to input terminal 0/2, this B switch is connected to input terminal 0/3, and C switch is connected to input terminal 0/4. Whereas whenever we are using the bell is the output, it is connected to output terminal 0/1. So this is the IO mapping. Whenever you are making a certain design of a ladder diagram, be very sure that IO mapping has to be clear enough. Without clear definition of the IO mapping, a process control scheme cannot be properly defined in a ladder diagram. So that should be very clear. And whenever I will be asking any of the such questions in your question paper or during our discussion, be very clear with the IO map. This is what is called as IO mapping in assignment. Okay, so let us next go for that. Now you see, we will try to design a truth table of the above condition. We will take each of the inputs as one of the switches. Okay, each of the switches, you can see this is the input from chairman, we have named it CH. This is the input from member A, we have named it A. This is the input from member B, we have named it B. This is the input from member C, we have named it C. So now you can see that if the input of the chairman is 1, then whatever is the input of the other members, the output of the bell should be high. The output should be high rather. The output or the bell should be high. So here you can see this is 1 and whatever is the condition here, this should be high. In other cases, in all of the other cases, what has to be done? At least 2 of the candidates should be high, then only the output will be high. So now you can see here, in first case we have made this chairman 0 because in this particular, these 3 lines, we are not considering the chairman, because if the chairman rings, definitely the first condition will be valid. Now you see here, this is member 1 is high and member 2 is high, that is member A and member B, both of them are high. Under such circumstances, output should be high. Then if member B and C, their switches are high, the output should be high. Or member A or C, if both of them are high, then the output should be high. Now you see here, 2 inputs are high, then only the output is high. This is possible with only AND condition. So you see here, the output is A and B, then it is B and C, then it is C and A. That means you have a high output when A and B is high, you have a high output when B and C is high, you have a high output when A and C is high. Therefore all the ANDs are there. Again, this CH is high, then also your output is high. So any of the condition of this will make the output high. So this or this or this and or this. So all of these links will be coming in OR condition. Let us see now. This is the first line. You can see over here, this is the chairman. Now these other members, they are all connected in AND format. They are in series and series. You can see here 2 3, you can see here 3 4, you can see here 4 2. They are all connected in series. And finally, either this or this or this or this, if any of the channel work, then the output should be high. Let us see now through the electrical figure. If I put this on, they are all normally open switches. If I close this, then the output will be high. If I close one of them, output will not be high. If I close one of them, the output will not be high. So if 2 and 3 want to choose a person, both of them should put their switches in on condition. Now one question you may ask, sir, if the chairman wants one person and other person also wants the same person, then what will happen? The chairman will put the switch on. Maybe the second member will put the switch on. But it doesn't make a difference whether the second man puts it on or off. Because once the chairman has put his switch on, the output will be automatically on. So this is how you can see that we have constructed a ladder diagram from a process description. And remember that whenever you are actually working with a PLC, or you want to program a PLC, you want to design a ladder diagram, whatever experiments that you perform in a laboratory, they are just child's play. You put it on, put it off, there is some timer operation, some counter operation. So actually there is such type of process control description in the real field. So whenever you are able to design the ladder diagram out of the process control description, then be sure that you are in the right path. And this is how the ladder diagram should be practiced. Now you see here what are the steps, because you see programming is an art and every person has a different approach to solve a particular problem. So for the same problem there can be different answers, no doubt, but there is some standard processes by which we can that can be helpful in deciding that how to design the ladder diagram from any digital circuit. First, design description has to be translated in the terms of truth table. So you should describe the design in terms of a truth table. then you have to try to minimize the logic using Boolean algebraic method or Carnot method that you have done in your digital coursework. And finally, you have to realize the logic, final logic that you have to implement in the ladder diagram. And then I would like to put some assignments in front of you. Already I have shared the PPT in its PDF form, so there is I don't think that I am to read this things. Things are very clear, self-explanatory. In each case, you are to design a ladder diagram or logic diagram. So I will stop here, and I will try to show you one or two actual problems that will help you to understand that how the logic things are developed. Okay, that I will show in the next lecture, because I can see that my okay, fine, I will be able to show you. There are several particular problems that I have made. I want to show you one condition. You see, this is actually the concept of go down wiring. So there are 3 rooms in a go down, and there are 3 toggle switches, S1, S2 and S3. Again, there are 3 bulbs, B1, B2 and B3. S1 corresponds to B1, S2 corresponds to B2 and S3 corresponds to B3. Now these things are evenly distributed across 3 rooms. Now we have to perform go down wiring for the 3 rooms. So what is go down wiring? That whenever the person will enter room 1, he will put the switch on. When he will put the switch on, this light will be definitely activated. Now when he will go to room number 2, then there is no necessity of light in this particular room number 1. However, the man will not go back to the switchboard and put it off. The man will go to the next room, and here he will be putting the switch 2 on. When he puts the switch 2 on, then automatically room 1 light will be off and room 2 light will be on. And such type of same action will be repeated when that gentleman will be going to room 3. Now here you have to apply the concept of interlocking. Especially the interlocking is a very interesting concept that actually I wanted to explain to you. Therefore, I carried out this particular program. Now, what is interlocking? Interlocking is switch contacts are designed to prevent a control system from taking 2 incompatible actions at the same time. That means ये स्विच कॉन्टैक्ट की एक ऐसी कनेक्शन है जिसकी वजह से आपको इतना पक्का हो जाएगा कि एट ए टाइम आप नहीं चाहते हो ऐसा 2 आउटपुट एक्टिवेट हो जाए। जैसे कि आपने अगर कोई इलेक्ट्रिक सर्किट बनाया जिसमें से ऐसा सिग्नल आपने एक इंडक्शन मोटर को दे दिया जिसकी वजह से एट ए टाइम मोटर फॉरवर्ड भी घूमना चाहता है, बैकवर्ड भी घूमना चाहता है, सो क्या हो जाएगा, आपकी मोटर जल जाएगी, इट विल बी डैमेज्ड. So in order to get rid of this situation, interlocking concepts is used. Let us see now how it actually takes place. Now you can see that this is the ladder diagram of the problem that we have discussed. There are 3 switches. I have named them X0, X1 and X2. There are 3 bulbs that I have named them Y0, Y1 and Y2. Now how I have put the interlocking, you carefully see. In the second rung, I have kept NC contact of the coil Y2. in series with the switch. And in first rung, I have kept this NC contact of Y1 and NC contact of Y2 to ensure that whatever has been asked in the problem, that can be achieved. Now let us see whether we are in the right path or not. So we will go to the simulator mode. We will go for compilation. We will download it to the PLC. Then we will take this thing in online mode, and finally we will put the PLC in run condition. Now you see here that all these NC contacts, they are now activated. So the person will enter room number 1, because in go down there are series of rooms, you cannot go directly to room number 2. You have to go to room number 2 from room number 1 only. This is a particular type of wiring, which is what is known as go down wiring. So I will put this on. You see, when I am putting this switch on, the first room light will be activated. Now the person will go to room 2. He enters room 2. Now he puts it on. When he puts this on, you can see here this particular light is activated. When this light is activated, the NC contact will be now open. Since the NC contact is open, this first room light is deactivated. Now the person will enter the third room. Here again he puts it on. When he puts it on, what will happen? This light will be on. However, these NC contacts which are present in both first rung and second rung, they will be deactivated. Under such circumstances, there is no question of this Y0 and Y1 to get activated. Now the person will go back in the same format in which he has entered the room. He has entered in room number 1, 2, 3. So how we will exit the room? 3, 2, 1. So first he will put this X2 off. You can see this is off. So when he puts this off, automatically when he will enter in the second room light is on. And next, from while exiting the second room, the person will put it off. When he puts it off, automatically the first room light is on. And when he wants to exit from the entire garage, then he will put it off. He will put it off, and the entire system will be now lightless. So now you can see that how simple automations can be achieved with the help of proper description of the process and proper understanding of the process. Once you understand the process properly, then there are n number of options by which you can develop a suitable logic diagram to see that the process can be happening automatically. So with this, I complete unit 1, and we will have a discussion on topics of unit 1 on Monday. That is, I feel it is 15th, and on 16th I will have a test of you on this unit 1. So whatever your questions are there in your mind, you can definitely note them, and we can discuss it on Monday itself. Thank you for your kind patience.